Spoiler alert, I'm giving out the answers to problems 8 and 9 on this one. So on number 8, all you do is fill in the blanks here. For inductance, you want to say blank leads blank by 90 degrees, and for the capacitance, you want to say blank leads blank by 90 degrees. And remember our friend Eli the Iceman to figure out what goes in each of those blanks. On problem number 9, the voltage that is given is in a cosine form with no phase. So this is the part that is given for the problem. That means that you can come right over here and write in V sub L as 10 volts because that's the peak value right there. And the phase is 0 degrees since there is no extra term. And if you look at this on a imaginary versus real axis plot, because that angle is 0 degrees, this is going to be only a real number. That means that the answer is just in complex form at least 10 volts. Doing the same thing for the impedance of the inductor. Recall from class that the impedance of an inductor is equal to omega L in polar form at an angle of 90 degrees. So go ahead and calculate this thing that we call the inductive reactance. X sub L is equal to omega L. Take the omega, which is right there, and take the L, which is given in the problem. I forget what it is, but make sure you convert it over to henries and not millihenries, and get a number that's in ohms right there. All you have to do after that is translate that over here and have a number in ohms right there at an angle of 90 degrees. And because this is along the vertical axis, that's going to be in the complex way a number in J, where J is the square root of -1. So don't forget to put numbers there and there. To find the current, what you do is use our Ohm's law. V is equal to IZ. That's Ohm's law for AC circuits, and then solve for I. And so you get V sub L over that. So take the part of the problem that you have already solved and plug it in. We can do this in polar form first. So we get 10 volts at an angle of 0 degrees divided by some number in ohms at an angle of 90 degrees from up here. And we're going to get some number in amps at an angle of 0 minus 90. So that means that what the answer that goes here is a number in amps at an angle of minus 90 degrees, and because that's along the negative imaginary axis, that's going to be some number in amps times J with a minus sign out here. All you have to do after that is take this number that you have here, put it right there. Take the omega that we have over here. Recall that frequency is unaffected by capacitors or inductors or even resistors in a circuit. So that's going to be 2000 pi radians per second. It appears that the only reason we needed that value is to find the inductive reactance in ohms. Make sure you multiply that times T, and the angle that we have for that is minus 90 degrees, and we're done. On the second page where it says continued, let's see if I can figure out how to quickly go about this. The peak values that we had was 10 volts and some other number right there. So we'll just go in here and say 10 volts minus 10 volts. And then we'll have our positive number in amps from the previous blank. I'm going to let you figure out what those were. So positive and negative values from the peak currents. Okay, and then alright, and then recall that this is what we had given in the problem, and that is omega So up here we can say omega is equal to 2 pi f is equal to 2 pi over capital T. This means that capital T is equal to 2 pi divided by omega, and since omega is equal to 2000 pi radians per second as given in the problem, that's going to be 2 pi divided by 2000 pi radians per second. This up here is radians. That gives us 1 millisecond. Pi's cancel out, 2's cancel out, we get 1 over 1,000, and then we have, look at this, the units here comes out in seconds, 1 millisecond. That makes it easy to label this. And since current and voltage have the same frequency, that means that that is the same value down here. The voltage was given to be a cosine function. It means it starts right here, ends right there, and has a minimum value right here. So just sketch that in. Doesn't look like I have that scaled properly. It looks like there's a bigger gap here than over there. Oh well, no big deal. Then on this one you see that it's out of phase by 90 degrees. Alright, so how do we deal with that? 90 degrees is 1/4 of 360 degrees. This means that the peak of this has to happen sometime in the future. So we got to take 1/4 of the wavelength and shift it over to the right hand side. Alright, so there is 1/4, 1/2, 3/4, and a whole. So we're shifting this cosine term over like that. Alright, so there you can see the phase shift. Let's make sure it makes sense. We have the voltage leading the current by 90 degrees, which corresponds to 1/4 of a wave. V leads I by 90 degrees. Does that make sense?